Hello everyone, in this video I will go over section 6.1, how to solve trigonometric equations. In order to solve trigonometric equations, you need to combine stuff you learned since the beginning of the class, and particularly the last section, which was section 4.7, which was inverse trigonometric functions, and also something that we've been doing many times by now, which is the special triangles. Okay, so basically to solve trigonometric equations, we're going to start with basic ones, and then in section 6.2 we'll do a little more complicated ones. So if you want to solve equations of this form, sine, cosine, or tangent, then you're going to need the inverse trigonometric functions for r sine, r cosine, which is sine inverse, cosine inverse, and obviously tan inverse. And then you either going to use the special triangles or just create a triangle to solve the problem. So essentially, you have solved these problems before. So for example, let's look to this one right here. It says, solve the following equations for x in the interval from 0 to 2 pi, which means you only have to find the answers in one period. Remember that we've been using this for a long time. Here all are positive, here only sine, here tangent, and here cosine. So this is where they will be positive. Now, since sine is positive, that means one of the answers is going to be here, and the other answer is going to be here for this particular problem. Now, the next thing is which reference angle gives you 1/2. And remember, if we go back to the special triangle which we have used many times, if this is 30 degrees and this is 60 degrees, remember this is 1, this is radical 3, and this is 2. So therefore, the reference angle that gives you sine of 1/2, it will be this. Sine, remember, is the opposite or the hypotenuse. So therefore, that represents 30 degrees. So therefore, the reference angle is 30 degrees, or pi over 6. So therefore, the first solution is the reference angle, which is pi over 6, or 30 degrees, which it represents this part. But also, if you are here, remember that the reference angle is 30 degrees, so this part has to be 30, so therefore the angle you're looking for is 150 degrees, which again, we have done this more than once. So therefore the second answer is going to be pi over 6, which is 150 degrees, or just 150. So as you can see, this is stuff that we have done before, so this is not necessarily completely new. Now here, let's say that the question, instead of asking you for sine equals to 1/2, that it was equals to minus 1/2. The reference angle will not change, it still will be 30 degrees, but since sine is negative, now the angle has to be here, because here and here is positive. So therefore, if you are here, the angle will be 210 degrees, or 7 pi over 6. If the angle lies on the 4th quadrant, the reference angle is 30, so therefore it will be 330 degrees, or 11 pi over 6. Okay? All right, so let's go to the next one. So this one is telling you tangent is equals to negative radical 3. Now, since this is negative, the first thing you need to figure out is what is the reference angle. So tangent is, again, see, you have all students take calculus. So tangent is negative in the 2nd quadrant and in the 4th quadrant. We just need to figure out what's the reference angle. So which angle gives you minus radical or radical 3. Forget about the negative for now. And if you look again to the special triangle, which we have here, notice that tangent of 60 degrees, it will be radical 3 over 1. So therefore the reference angle is 60 degrees or pi over 3. So therefore the first angle, and this will also show you that even though you need a reference angle to find all the solutions, the reference angle is not necessarily one of the solutions. It was for this one, but notice that here the answer is not a reference angle, but you cannot get this or this without a reference angle. So in this case, since the reference angle is 60 degrees, if you are in the second quadrant, if this is 60, well, this has to be 120. So the first angle is 120 or 2 pi over 3. The other angle is if you are on the fourth quadrant, so the reference angle is again 60 degrees. So therefore the angle from here to here, it will be 300 degrees or 5 pi over 3, which is also 300 degrees. You should look at this as 5 times 60 is 300 degrees. So as you can see, this relies 100% on the reference angle and also the special triangle. Now, what about if the thing is not at the special triangle? So for example, let's say you would have sine of x is equals to 0.2. If this is the case, then you're going to need a calculator. X will be whatever sine inverse of 0.2 is. You will need a calculator for that, and this will create the reference angle. We will talk more about this one in the next video. For now, we'll just focus on values that are exact like this. All right, so let's do a few more examples. So sine of x is a positive radical 3 over 2. So again, since sine is positive, that means the first angle has to be in the first quadrant and the second one on the second quadrant. Since the value is radical 3 over 2, again, if we look to the special triangle, if this is 60 degrees now, notice that this is radical 3, this is 2, this is 1, and this is 30 degrees. So therefore, the reference angle for this problem has to be 60 degrees or pi over 3. So therefore, the first solution is going to go from here to here, which is 60 degrees. So in this case, the reference angle is one of the answers. Or if you're in the second quadrant, since this is 60 degrees, this one is 120. So therefore the the second angle is going to be 120 degrees or 2 pi over 3. All right, so now we're going to do problems that are a little bit more complicated, which is going to require algebra. So just think you're solving a problem like this. Look, if you're going to solve x squared equals to 1/2 x, the first thing you do, you say this equals to 0. You can factor the x, and then this will be x minus 1/2, and therefore the solution, it will be 0, and it should be 1/2 if this was the equation. Now, this is not the equation. This is the equation, but it's very similar to this. If we follow the same idea here, notice that you will end up with this factorization: cosine x times cosine x minus 1/2 equals to 0. And therefore this will mean cosine x will be 0, or cosine x will be 1/2. And now this will be a problem like the first three we did, and so is this one. Now the only angle that gives you 0 for cosine between 0 to 2 pi, remember that the graph for cosine looks like this, and at this point it's 0, but that's 90 degrees or pi over 2. So therefore here x is either 90 degrees or pi over 2. That's the answer for that one. Now, if we look to the special triangle, cosine of 60 gives you 1/2. So therefore x is equals to 60 degrees or pi over 3. Okay. All right, the next one, you can either do factoring or use the square root property. If you factor, remember, let's say you want to factor x squared minus 1 equals to 0. This factor as x minus 1, x plus 1, and then the solution is either 1 or negative 1. So therefore here, if you factor, this will be tangent x minus 1 times tangent x plus 1 equals to 0. So this means tangent of x is equals to 1 or tangent of x is equals to negative 1. Okay. So now these are essentially two problems. And remember, each problem from number 1, number 2, and number 3 has two solutions. So this one we had two solutions, and this one will have two solutions. Why? Because if we go back to this basic thing, all the students take calculus. So the positive answer for this one is going to be in this quadrant, in this one. And therefore the negative solutions are going to be in this one and this one. But all of them are going to use the same reference angle. The only angle for tangent that gives you 1 is 45 degrees. That's, again, one of the special triangles we used before. So this is the reference angle. So therefore, if you are on the first quadrant, well, yeah, theta is 45 degrees or pi over 4. But if theta is on the third quadrant, which will be here, since the reference angle is still 45, so then you will have something like this. And this one is 45 degrees. So the whole angle is 225. So this is 225 or 5 pi over 4. Now on the negative side, if it is negative, so let me color code this. So if it is positive, it will be here and here, which corresponds to this one and this one. And if it is negative, it will be in the second quadrant and in the fourth quadrant. So in the fourth quadrant, then theta, which by the way, when I say theta, I always mean x for this value. So x. So for this case, then x is going to be equals to 135 degrees or 3 pi over 4. How do I get that? From here to here is 135. You should check that since this is 45, because 45 plus 135 gives you 180. And if it is in the fourth quadrant, then x would be 315 degrees or 7 pi over 4. All right, so let's look to the last problem here. Notice that if you were going to factor this, like x squared minus 3x plus 2 equals to 0, you can factor this as x minus 2, x minus 1. So the answer will be 2 and 1. So in this particular case, then you can factor this as sine x minus 2, sine x minus 1. So therefore, sine of x equals to 2 or sine of x equals to 1. Now, the only one that gives you 1 is 90 degrees. So that means x is 90 degrees. By the way, in the previous problems, I used theta to mean x. So just watch out for that when you review the notes. So x and theta are used interchangeably in this video. So this is either 90 degrees or pi over 2. Now for this one, okay, you have to be very careful here. So note that this one has no solution. Why? Because sine always has to be between -1 and 1. So if you get a number that is more than 1, it automatically has no solution. So the only solution to this problem is either 90 degrees or pi over 2. In conclusion, solving trigonometric equations requires familiarity with trigonometric functions, identities, and mainly inverse functions. So practice and understanding these concepts are essential to mastering the topic. So specifically, make sure that you review the two special triangles. We have used this now like 100 times, and we're gonna keep using them the whole semester. So I highly recommend you work on this. So remember the two special triangles were this, and this is 1, 2, radical 3. This is the 30, 60, and the other one was the 45, 45 degrees. Okay, and that's it for this video.